Now on page 3, you'll see the formulas for absolute and relative change. That's page 3. So for absolute change, it's always the old value, it's always the new value minus the old value. So it's new value minus old value, and that corresponds to absolute change. Now, relative change is going to be the absolute change, or the new value minus the old value, divided by the old value, and that corresponds to relative change. So now, let's say we bought a house for $150,000 and sold it for $180,000. So the new value is $180,000, and from it we're going to subtract $150,000, our old value, and we get a difference of $30,000. And so that is the absolute change in the value of the house. Now let's find the relative change. So to find the relative change, so this is the absolute change. To find the relative change, we take this difference, which is $30,000, and we divide it by the old value, what we initially paid for the house. And let's see, that was $150,000. And as you can see, those zeros divide out. Let's see, we get a couple more zeros to divide out. The dollars, those units divide out. And 3 goes into, this reduces to, 3 goes into 3 once and into 15 5 times. So that's 1/5. And when we turn that into a percent, that corresponds to 0.2 or 20%, and that's the relative change. So we have a relative change and we have an absolute change. The relative change is always a percentage. Good. Now, excuse me, we're going to use or do example 14. And in this section they're talking about proportions and ratios, and a proportion is, as you can see on page 6, is just an equation that equates to ratios. But for example 14, the book does it using proportion. We're going to do it using dimensional analysis, because dimensional analysis is absolutely important. It has so many applications, and we want to reinforce that skill. So once you get it, you'll find it quite simple. We also need unit multipliers. Or a unit multiplier. And a unit multiplier is a ratio that it just equates to 1. So this, will you agree, for this problem it's stated that 3 miles on the Earth equates to 1/2 or 0.5 inches on the map. Now if we divide both sides by 0.5 inches, 0.5 inches, what we get is 3 miles over 0.5 inches, which equals 1. Therefore, this is a unit multiplier, because it equates to 1. So relative to this problem, we can multiply a piece of data by 1 in this form. So we'll, anytime we use dimensional analysis, we'll start off with the value about which we're trying to resolve, in this case, come up with the corresponding amount of miles. So that's 2.25 inches and over 1. And then we'll multiply by the unit multiplier that will enable us to divide out what we don't want, the units we don't want, which are inches, and retain the units we do want, which are miles. And as you well know, the inches will divide out. They're in opposite positions, numerator, denominator. And so now we have 2.25 over 1 times 3 miles over 0.5. And I'm going to tag a 0 on there. Now look, wouldn't it be nice to get rid of these decimals? Well, we can do that. If we move this decimal 2 places to the right, we can do it as long as we move this decimal 2 places to the right. We did it in the denominator. We also have to do it in the numerator. So now we have 2.25 times 3 miles over 50. And 50 goes into 225 4.5 times. And 4.5 times 3 miles is 13.5 miles. And that would be the distance on the ground traveled, corresponding to 2.25 inches on the map, and we're done.